Okay, children. Now what we are going to discuss is type of rate of reaction. This is a part of chemical reaction. That is the next topic that we have to start. That is type of rate of reaction. Under this type of rate of reaction, we are going to discuss different types of rate of reaction. The first type is we call average reaction rate. That is called what? Average reaction rate. The first one is average reaction rate. The average reaction rate is something like that, concern the longer period of time and then longer change of the concentration, longer change of the temperature. Like that we take the data for a broader range of time or broader range of instances. Then the second type of rate of reaction is the second type of rate of reaction we call instantaneous reaction rate. We call that is instantaneous. That is called instantaneous rate of reaction. That is called instantaneous rate of reaction. Right? Instantaneous rate of reaction is the next one. The next one is instantaneous rate of reaction, and there's another one that we call initial rate of reaction. The next one is what? Initial rate of reaction. The next one is initial rate of reaction. Right. So initial rate of reaction. Next one is now we have another type. The next type we call the fourth type, that is called lowest rate of reaction. We call that is lowest rate of reaction. Right. So now here in this types of rate of reaction lesson, we are discussing different types. The first one is average reaction rate, instantaneous reaction rate, initial reaction rate, and lowest reaction rate. Right. So likewise there are four types of rates of reaction that we discussed. Right. Now for an example, if I concern what is average reaction rate is, now if I want to discuss what is the meaning of the average reaction rate is, so when I concern what is this average reaction rate, average rate of reaction or average reaction rate. So what is this average reaction rate is? That average reaction rate we can determine by an example like this. I will take an example like this. You all know this is C2H4. We call that is ethene. Ethene is reacting with the molecule called ozone, and then ethene is a gas, ozone is a gas, and then it makes a new molecule, that is C2H4O plus what? Oxygen. This reaction you will learn in the environmental chemistry section. Why? This is the reaction. This reaction is responsible for the photochemical smoke, right? That we have to discuss later. Anyhow, this is how ethene molecule react with ozone. In this reaction, how fast the ethene molecule concentration decreases, same fast that oxygen concentration increases. How fast this concentration decreases, same fast the reaction happens. How fast the ozone concentration decreases, same fast the reaction takes place. Right. So if I find the rate of decreasement of ozone concentration, that means I have found the rate of reaction. Right. So respected to the ozone concentration and respected to this concentration, we can express the rate. For this one, I can say this rate is equal what? As this concentration is decreasing negative, delta means change, you know that. The box bracket is a concentration of C2H4 gas, and then how fast that concentration change, means this is the change of concentration of ethene per given change of time. So that is the rate of reaction respected to this thing. Similarly, we can measure the rate of reaction. Similarly, we can measure the rate of reaction like this respected to oxygen, ozone concentration. Ozone also decreasing. So then the change of concentration of ozone gas, right, per a given time period, that's the rate of concentration changing of ozone. Now look at here, if I want to study the rate of this reaction, I can study how fast the ozone concentration decreases. How fast this ozone concentration decreases, same fast the reaction happens. So the one who wants to study the rate of this reaction, he wants to study how fast ozone decrease or how fast oxygen produce respected to ozone, respected to oxygen, or respected to any other factor. We can measure the rate of reaction, right? So that is how we find the rate of reaction respected to these things. Now we will concern a table like this, right? Now you can see here a table, right? Now first we have to know, we are going to discuss this reaction, that is C2H4O reacts with ozone and it makes this an oxygen. Right. Now we will concern what happens to the ozone concentration with the time. This is the time. Time is measured in every 10 seconds. Here 0, 10, 20, 30, 40, 50, 60, like every 10 seconds I have measured the concentration of ozone. When I start, when the reaction start, ozone concentration is 3.2. After 10 seconds, ozone concentration is 2.4. After 20 seconds, 30 seconds, you see that when the time passes, ozone concentration decreases. That means when the time passes, ozone concentration is decreases, means reaction happens forward direction. So how fast the ozone concentration decreases, same fast the reaction happens. So if I am interested about the rate of this reaction, I will find how fast the ozone decrease, same fast the reaction happens, right? So when we concern that thing, how fast is ozone concentration decreases and all, right? So we can say that this axis is concentration of ozone, right? So I will draw another one, right? So imagine this this is my table, right? I can't take all these to one view, so then I will take it like this, right? Imagine that for this axis, right, for this axis I will take ozone concentration, right? So for the y-axis I will take ozone concentration of the ozone. This is the concentration of ozone. We will measure that in moles per cubic decimeter. And for the x-axis I will take time, right? I will take time for the x-axis, so it will be like this, right? So the x-axis is what? X-axis is actually time. X-axis is, this is the x-axis and that is time. So now what will happen, as you see earlier, now when the time passes, ozone concentration decreases. When the time is passed, this axis is a time, you know, I will write here time, right? When the time passes, ozone concentration decreases, like this. You see that when the time passes, ozone concentration decreases. So how we study this? It will be like this way, right? The ozone concentration when the time pass, ozone concentration decreases, like this. When the time pass, ozone concentration decreases. So now look at here, at the beginning, this is the point which we start, right? That is the point we start. So and this is 60 seconds, right? So so let this one to be 60 seconds, right? This is time, and this is 60 seconds, and this is 0 time. The time is 0 here. When the time is 0, concentration is 3.2. so then the highest concentration, that is 3.2 into 10 to the power minus 5 or something, right? So then the next thing is when it is 60, the lowest concentration is 1.1. so somewhere here the concentration will be 1.1 into 10 to the power minus 5, right? So then I got this kind of graph. So now we remember, earlier we discussed there are different types of chemical reactions. Or the reaction rate. There are different types of reaction rate. The first one we discussed is there were 4 types of reaction rates. The first one, average reaction rate. So how can I find the average reaction rate in this kind of graph, right? Average reaction rate can be determined like this. If I concern average reaction rate, means I will concern this as a final initial concentration, and I will concern this as the final concentration, right? Initial concentration is this one, because that is the concentration when the time is 0. Final concentration is this one, because that is the concentration when the reaction is finished. So how to find that the type of reaction? We know that there is a type called average reaction rate. How can I find the average reaction rate? I will draw a tangent. From here to here, or I will draw a line from here to here, right? This line, let it be A. This A line represent average reaction rate. So the gradient of this line is the average reaction rate. Now you can feel that average reaction rate is a common value for any reaction rate. At the beginning, reaction rate is very high. Here the reaction rate is low, right? But average reaction rate is always constant value. Average reaction means average reaction rate. Average rate of reaction or average reaction rate means concerning starting point to the end point, we give the average value. This is the normal rate of reaction. Now if you are traveling in a bus, the bus may be travel fast when no color lights, but when the color lights come, bus is slow. So but we can say that average velocity of the bus, right? Something like that. So this is throughout the journey, average velocity is said. Average reaction rate is taken in a way that concerning the broader range between the 2 points, right? So that is what the average reaction rate is. Okay, then average reaction rate, we can find the average reaction rate like this. So if I want to find the average reaction rate for this particular reaction, actually if I want to find the average reaction rate for this particular reaction, so it will be like this, right? That if I want to find the average reaction rate for this particular reaction, it will be like this, right? So you need to know average reaction rate, right? So that is average reaction rate. Average reaction rate is equal to what? Respect to ozone we concern, there should be minus sign, therefore, right? Decreasement of ozone concentration, right? change of decreasement of ozone concentration divided by change of time. So for that we have to concern minus final ozone concentration minus initial ozone concentration. What is the final ozone concentration? They are right. What is the final ozone concentration? Final ozone concentration is 1.1 into 10 to the power minus 5. Initial ozone concentration is 3.2 into 10 to the power minus 5. So we can get the values for this one, that is ozone concentration final, right? Ozone concentration final is how much? That is 1.1 into 10 to the power minus 5 minus initial ozone concentration 3.2 into 10 to the power minus 5, right? Close the bracket. The time taken, how much the time taken for this whole process? What is the time taken for this whole process? 60 seconds. So that should be divided by 60, right? Here the unit is what? Moles per cubic decimeter. Here the unit is what? Seconds. So then we got the answer like this. The final answer, if you solve this problem, you will get 3.5 into 10 to the power minus 7 moles per cubic decimeter per second. So that is how we find the average reaction rate. So remember, average reaction rate is concerning initial point and final point, match the initial point and the final point, and the gradient of that is equal to average reaction rate. I said it is simple A. This is a one method to find the average reaction rate. Or using the table, using this table, right? Using this table we can find the average reaction rate like this, right? So that is what the average reaction rate is, right? Now there is another one that is called instantaneous reaction rate. I said there are 4 types of reaction rates. There is another type of reaction rate that we call instantaneous reaction rate. Remember, there are 4 types. Average reaction rate, I discussed that. The other one is, second one that we have to discuss is instantaneous rate of reaction. Instantaneous rate of reaction means what? What is the meaning of that? Instantaneous rate of reaction. Actually, instantaneous rate of reaction means the rate of reaction at any specific time they highlight. Now for an example, say this is the 18th second. I don't know, just imagine this is 18th second. So I want to find the rate of reaction at the 18th second. So what I will do, right? I will expand that line from that 18th second, and then I will draw a tangent from that place. I will draw a tangent like this. From that place. Okay, I will draw a tangent like this, right? From that tangent that I drew from that place, I will find the gradient of that tangent. That will be the instantaneous reaction rate. I will say that is D, right? I will use the simple D for that. I just arbitrarily take this D value. It is not a symbol, right? Okay, so that is for the instantaneous reaction rate, right? Then there's another one that we call initial reaction rate. What that initial reaction rate is? Initial reaction rate is something like this. Initial reaction rate means the reaction rate at the beginning. Actually, the initial reaction rate should be the highest reaction rate. initial reaction rate should be the highest reaction rate, because this is the time, initial time. At that time the particles of reactants are maximum, so the collisions are maximum, therefore the rate of reaction is very high at the beginning, so that is the highest one. So initial rate of reaction we can find like this. We draw the tangent like this, right? To find the initial rate of reaction we draw a tangent like this way, right? I guess you can see the board, the page, right? Initial rate of reaction is find like this, right? So that initial rate of reaction, I said letter I, just I say the letter I for the initial rate of reaction. Using drawing the tangent from the 0th second concentration, we got the initial reaction rate, right? Similarly, we have another one, lowest reaction rate. The lowest reaction rate we can find by drawing a tangent like this, right? So now I told you there are 4 types of reaction rates. Actually there are 4 types of reaction rates. One is average reaction rate, instantaneous reaction rate, initial reaction rate, lowest reaction rate. The student need to know what is the meaning of these 3 and how do we find these rate of reactions are, right? So that is one part that we have to discuss, right? Okay, then